Yeah, so we will talk about the adaptive platform today. And well, I'm Martin Lunt. I'm representing Bosch in the PL team. And I will do this presentation today together with Nadym. So maybe
yeah, I'm Nadym Salem. I'm on the bright side. He's on the dark side of AUTOSAR. And I'm the technical manager for the adaptive platform.
Okay. So what is our presentation about? Which one is it? This one here. Yeah, so we will give a quick overview about what's going on in the adaptive platform, similar as Pingley has done it. We also will talk about a particular released feature, and then I will also talk about the AUTOSAR Automotive API. You have heard a couple of things about that yesterday already. I will go a bit deeper into the technical details so that you also get a better feeling what it really is. And of course, we will end with a conclusion. Yeah, so maybe next one, if you would like to.
Yes, so I mean, Pingley already showed a little bit of an overview of the comparison of adaptive and classic platform in AUTOSAR. And we started comparing this a little bit with a brain model. I'm definitely not a brain expert here, but what we have also in our human brain is like the brainstem handling the reflexes and really fast real-time requirements, if you wish. And we compare this with things that we can do with the classic platform, where we have really hard real-time requirements, usually the sensor actuator ECUs that are handled well throughout the last couple of years, if not decades already. We do have on the other extreme the cerebrum for really conscious decisions that we take. So deciding to stand here and present in front of you. That usually handles strategies, more long-time planning decisions. And that's something that we handle as of today with the rather adaptive platform, where we have microprocessor hardware with well, higher computing power, and of course also real-time requirements, but not as hard real-time requirements as on the other hand. Well, you could stick to that one for a sec.
You mean back?
Because we also have this middle layer, which is handled by the cerebellum. So you have unconscious cognitive decisions in the brain, but also you have core vehicle functionality being handled. And that's something you could, well, depending on the project, depending on the requirements of the project, handle with classic platform or adaptive platform, because that's kind of the layer in between. Yeah. Want to continue?
Yeah, so you can now try to bring this model into the vehicle, as you can see here. So the color code is exactly the same. You have the central computing systems, which are very powerful, which are doing, so to say, the conscious decision. And there we really have usually microprocessor systems with AUTOSAR adaptive platforms inside. Some of them also contain classic platform systems just for supervision purposes, but the main computation is done by adaptive platform systems. Then we have the zone ECUs. There we have mainly microcontroller systems already. So this is more classic platform systems. And then we have, of course, also the ECUs at the end, so controlling all the sensors. There we have, yeah, the classic platform. Yeah.
Yep. So what we'd like to give you is a short overview, and maybe most of you know that already, but of the adaptive platform. And I think the big difference to what Pingley showed for the classic platform, where we had a clear layer software architecture, is here that this picture might even look like a layered architecture, but that's more to the size of the slide. These are functional clusters that are more or less in parallel, can be used, and that provide APIs or services towards the application, covering different functionalities within the platform. And we don't have this clear or very, very detailed specification of every single API to the last bit and configuration of the modules like we have it in Classic Platform. That was one initial requirement when we started with the adaptive platform back in 2014. But we cover all the important parts of a software platform, starting with the communication on the left side, of course, core functionalities like the POSIX PSE operating system interface below. We have storage like persistency here, for example. We have security mechanisms, so identity and access management and crypto, to name some. We have logging and tracing. We have the classical vehicle diagnostics features, and so on and so forth. And of course, on the other side, on the right side, there's also things for update and configuration management to be able to update these ECUs on the over the air.
Yeah, maybe it's something we should mention is that these systems are designed to run in hypervisor partitions. So this is exactly one of the basic requirements we had right from the beginning, so that we can have different instances in one vehicle, so that we really can put it on these central computing systems in many instances. Yeah, so what is maybe the difference also a little bit in comparison to the classic platform? So we have, of course, our specification. I think it's very important for systems which shall be used in an ASYL environment. So for ASYL systems, it's definitely necessary to have requirements and specifications. But we also have a demonstrator. That means we have an implementation which is developed by AUTOSAR itself. And so we are trying out what we are specifying on the left side, so to say. And this also helps us to improve the quality of the specification. So if you're implementing something, you immediately find out, okay, there is maybe a bug in the spec, or it's not readable or not well understandable. So this really helps to improve the quality of the specification. And also, if it comes to integration, it has definitely advantages, because such a complex system is hard to overview or to be overviewed by a single person. So if you run it through a compiler, a toolchain, and a linker, then you can immediately find out if there are some interfaces not matching to each other. And of course, you can use it for training purposes as well. And yeah, there is also a demonstrator available, so we can use it for showcases. And you might have seen the PyCar outside, so there you can see what, so to say, live how the adaptive platform looks like, or what you can do with it.
Yeah, so you saw Ping Lei's overview at the very end after the question with a lot of features upcoming, so not all of them will come this year. But we also released quite some features in the last year for Adaptive Platform and Classic Platform. Showing all of those here would definitely exceed the time limit that we have, so we just wanted to show one example. I mean, if you're curious about more, you can get in touch with us afterwards in the break, or contact us later. That's, I think, always available, of course. So an example out of the security area here, since security from our perspective is one of the core functionalities in AUTOSAR, because we need to kind of have a holistic security approach across the platforms. And I mean, we heard a lot about software-defined vehicle, about cloud communication, and of course, the more you have access from the vehicle to cloud, to the internet, the more security requirements will become important, or are important already, of course. I mean, we all see the news with all those attacks. We heard yesterday in the keynote quite a bit about it. And thus the firewall concept is something that is quite crucial for a vehicle as of today, which was maybe not even important 20 years ago.
I think the main thing here is to have a consistent configuration of all these firewalls you might have in the system. And that's exactly what this concept is heading for. So you can see we are having a release now for the adaptive platform, but we are planning to have something also for the 2311 in the classic platform, so that you can have a really consistent approach and not run into lock-ins and things like that. Maybe also one very important thing is you can also bring it to the switches, and even if the switch does not have an AUTOSAR implementation on it running, we have mapping to the, it's possible to have a mapping to the firewall, to firewalls which are running on switches. So this is how we are trying to integrate also non-AUTOSAR solutions in the system.
Yeah, so we saw also on Pinglei's slide, classic platform is really established in the market. We have most, if not all of the cars having at least an ECU with classic platform. For that adaptive platform, by nature, the amount of ECUs is lower, since we have those central large ECUs where you usually don't have 20 or 30 of them in the car. So the overall amount of ECUs is lower. Nevertheless, adaptive platform is already in the market. We have production running with adaptive platform in the market. And so, yeah, it's proven to be ready for mass production. But of course, there's still a lot to do. And we have feature roadmaps showing what's missing. We have, I think, also changing requirements as of today compared to what we had 2014, maybe when we started the adaptive platform, which need to be somehow reflected in the future development of the adaptive platform. And that's what we're definitely considering, because we think standardization is key for the success. We don't want to go back to proprietary solutions to the very extent that we had maybe end of the 90s. And thus, we think that it is already the start of a good success story, but are working on it to continue.
Okay, so but let's now have a quick look at the AUTOSAR Automotive API. So there also was it was also named as Vehicle API. So this is exactly, we are talking exactly about the same thing here. We think AUTOSAR Automotive API is the better term, because it's not just only running into a vehicle, because it also can run in the cloud, and then you have hopefully the same APIs. So if you use it for testing, then it's not just in the vehicle, so you can keep the software exactly the same, and of course you will keep the interfaces also the same. And yeah, let's come back to this human brain model, and now we are talking about communication and what's necessary if you want to communicate with different people. Yeah, of course, when they want to talk to each other, they have to talk the same language, right? And language consists of grammar and vocabulary, and I think this is very important. Yeah? So if you have the same grammar, but if you are using different words, then you would not understand each other. And this is exactly what we are talking about here. So we have also to specify the vocabulary which we are using. And also, you also have very often the case that the people do not talk the common language. They usually talk their own language. But of course, you can solve this problem by translation. So someone who's just talking Chinese or Japanese, if you translate it to English, then everybody can understand each other. And AUTOSAR also has something like a common grammar today. Let's call it ARACOM. But we do not have the common vocabulary. So we can use the protocol and the interface description, but the content needs to be much more precise if you want to achieve certain use cases. We will sketch that in a moment. Yeah? So that's the basic idea, to have this common language. Once again, bring it to the vehicle, and we are talking to the cloud, and the cloud is talking to other vehicles, and therefore it's necessary to have this common language. And here I would like to point out that we are using the VSS catalog. So this is a vehicle signal specification which has been defined by Covesa. So that's definitely the reason why we are concretely collaborating with them, and just to use, so to say, the same vocabulary which is already defined. So we are not reinventing the wheel, we are reusing what's already existing. So yeah, and this is some use cases where I would like to justify why such a common language is useful. So let's talk about Zara. She is managing a car sharing company, and of course she has different vehicles, so different vehicles from different vendors, and also different sizes. Yeah? So if she is buying vehicles, then she can buy, she will get a certificate and a key which can be used to maybe later on to use it in an app, because she has customers like Joe and Lynn, and they of course like car sharing, but they don't like to use different apps for each and every car they want to use, right? So they want to have a single app for the different cars they would like to share. And they also would like to use this app with other car sharing providers, and because then the possibility to get the respective car is much higher. Yeah? And this is the reason why it makes sense to have a standardized interface so that they just can use a single app, that they can have a single setups, and they, for example, can just authenticate and register once, and then they just start a sharing request. They will get a timely restricted key, and then they can do the ride. Yeah? So then it's really easy to make this use case possible. And this is exactly the idea of having a standardized interface, and this only works with standards, because if each and every vendor, OEM, has its own interface, this would not be possible. Yeah? Then you have to have an app for each and every single car.
And even on top of that, you could picture them using the app and even having the seat settings, the mirror settings, whatever, in the app, and it can work with every single car. So they're going into it, and the car gets the information and does all the settings that they want. And that's where AUTOSAR again comes into place, because then we need to support this interface, of course, and across vendors. Right,
and there's another use case. I think it's also one which is a bit more safety relevant. You can imagine that you have an icy road there and, on the right side of this picture. And of course, the first car will recognize, okay, there's ice on the road, you have to be careful, it also might break, so the ESP will recognize it. But this information can be shared. So you have to identify the position of the car, you have to know where the car is, and you can send it to the cloud to update the friction map. And then this information can be shared with all the other cars, which are in the same situation. So of course you can share it also with the cars of the other roadside, but they should not care, or they should not react on something which is on the other side of the road. But for all those coming later, they are really interested in such an information. Yeah, and you can bring it to the panel so that you can see a warning message, but you also can really do an interaction with the engine or even with the brakes. Yeah, so we have you can brake the car or de-accelerate at least the car. So, and here, of course, you can imagine there you have definitely safety requirements. You must trust the information you get. Yeah? So it does not make sense to do some actions on information which is wrong. Yeah? So then you really might confuse the driver. So that's, I think, very important that here we are also not just having some QM use cases, it's really a safety relevant use case. So now I would like to give you a kind of orientation where this vehicle API in the architecture can be located. So, and you can see a picture which has been shown yesterday already by Michael, by Michael Niklas. And you can see on the left side the computation platform, which is in the vehicle, but you also can see on the right side the cloud. And you can see the automotive interface, the automotive API here. This is for both sides. Yeah? So that's also the reason why we named it to automotive API, not just to vehicle API, because it's really across the different platforms. And yeah, I also think it's very important to understand that these complex systems can only work if we have standardized APIs. Yeah? And so the vehicle API or automotive API is in that area. And now we are going a bit more into the details. So how does such an API look like? So we have the AUTOSAR system here below. So and the AUTOSAR system talks ARA-COM. And of course, you need an adapter to connect to this system. So you have ARA-COM on both sides, on the AUTOSAR system side, but also on that gateway side, so to say. And there you have a data mapper which converts, so to say, the semantics here coming from this system into something which is understandable as a common language here on top. So there you have the automotive API. And then you need to have, so to say, a connection handler which supports the different protocols you can have. So here we are talking about MQTT, HTTP, DDS, maybe some IP. But there are also others thinkable, of course. And I think it's also very important to mention that this mapping needs to be generic, because we are not talking about, let's say, 5 signals. We are talking about hundreds or thousands of signals which are already existing in today's systems. Yeah? That's the reason why we want to make use out of the AUTOSAR description we have for those signals. And then, of course, a tool can do such a mapping to provide the individual adaptation of the AUTOSAR systems here below. Yeah. So here you, as shown in the slide before, you have different systems talking different languages, but we are always translating it to the same language here on top. Yeah. Just to close the loop. And, well, that's maybe also something worth to mention, because we are not talking about something which has been invented by AUTOSAR on its own. So we want to collaborate to develop this the system together with other standardization boards like Covesa and Eclipse SDV. And yesterday, Michael Plugge also mentioned the Cuxaval project. So the Cuxaval, for example, is already implementing this automotive API here on that level. It's called Data Broker. And what we need now is we want to close the gap using this, or we have to describe this data mapper, and then we can connect these two things. And we really want to have it as an open source. Yeah? We want to have it as something which can be used by other partners. And that's exactly the reason why we are using a different contract for it. This is what Thomas Rüpping mentioned this morning. So we will have it, we will develop this part in a new context, under a new, or in a new setup for the teams, so that they finally can collaborate also with non-AUTOSAR partners, and that non-AUTOSAR partners can use this interface. And well, that AUTOSAR becomes more open. This is the idea, to bring this opening strategy also to the other boards who would like to collaborate with us. And that's here we have the AUTOSAR license. This is the red one, and here we have this red and white one, which shall, so to say, indicate that we are talking about open projects here. Okay, so that's the last slide for the automotive API, and now we
would like to wrap up. So we are introducing new EE architectures. I think we've heard that throughout pretty much every talk yesterday and today, and I guess it'll not change in the upcoming talks. We have all those changing EE architectures. We see the adaptive platform as an essential part for this new architecture, and we're willing to take the requirements from all the automotive partners, but also from the non-automotive partners when we're talking about vehicle API, for example, and try to evolve the adaptive platform further into a platform that can be used for all these tasks that we want to perform. And for us, the adaptive platform complements the classic platform, so it's not an exchange of the one against the other. It's just different use cases, and I think that has been clear throughout at least the last talks. And the AUTOSAR Automotive API is then going to be the first open project. And Michael talked yesterday a lot about the open framework too, and Thomas this morning as well. And we're happy to do this in collaboration with Covisa, to then ease the communication to the outside world, and be it cloud or maybe also direct connection to smartphones or whatever. Thank you very much.
Thank you very much. Martin.